Welcome to the Flash Performance Garage, where today I'm going to teach you magic. I'm going to show you how to turn a computer into a brick. When it comes to computer programming, there's one key feature that a lot of people overlook or forget totally, and that is voltage. Whenever we're programming a vehicle via a J2534 box, we have to make sure that we maintain the proper voltage in that vehicle throughout the entire programming session. We're going to go through the difference between a battery maintainer, a battery charger, and a stable power supply, how they work, and what the difference is in each one. So here's my scientific method to show you the difference between a battery maintainer, a battery charger, and a stable power supply. I got all these from Schumacher, so I'm going to stick all with one brand, so we're taking that out of the equation. I have my 4-channel lab scope. This is a maxi scope. I'm running it on a Windows PC. This is Windows 10 on my Surface tablet. I'm going to show you the differences in voltage, amperage, and AC ripple coming out of each individual maintainer, charger, and stable battery supply. One of the things you want to remember when programming is you want to maintain a specific voltage. You don't want it to change, and you have to maintain zero or as little AC ripple as possible. Now, I'm also going to load down the battery to see how the voltage changes during that load, because when we're programming, we can put a very heavy load on that vehicle, sometimes in excess of 70 up to 100 amps on some vehicles. So we want to make sure that we can maintain that. I don't have a whole lot of confidence in this charger because this is a battery maintainer and it's rated at 6 amps 12 volts. So as soon as we go over 6 amps, we're going to go right past that option. So you can see on my scope screen, I have channel A, which is in red. That's going to be battery voltage. I have channel B, which is in green. That is going to be our AC ripple. And I have channel D as an amp clamp. So that's going to show us how much amperage we're pulling. So currently you can see that we're right at 12 volts on our battery voltage. So I have a good battery. I have no amperage going through my battery charger cable because I don't have the battery charger plugged in, and I have no AC ripple. So let's go ahead and plug in the battery charger. And we can already see a little bit of static coming through the voltage. So we see the voltage is oscillating up and down, but we also see the channel D in purple. We're pulling about 2, maybe 2.5, 3 amps. So we're not quite at 4 amps. So it's analyzing the battery and it will start to cycle that different load. So we're going to go ahead and pause the screen and we're going to take a snapshot and so we can see what's going on. So if we look at amperage in purple, we're about 4 amps. Voltage, we are ranging anywhere. Let's go ahead and zoom in a little bit more. We are ranging on voltage up to 13.5 volts. And then we'll change that down again. So we're looking at 13.5 to 11.47 volts that we're alternating between on this scale. So if we take this and we look at our AC ripple, you can see that we have tons of ripple coming through that line. And when we talk about ripple, we're talking about noise. This is noise coming through the network. So this also means that all that noise is going to be on your CAN bus network whenever you're trying to program a vehicle, and that noise causes issues. So let's see what happens. We'll go ahead and zoom out on this. We'll go ahead and turn it back on. It's live now. I'm going to take my measurements off. And we're going to see what happens when we load this down. So I'm going to put a load on the battery. And specifically, let's watch and see what the voltage does. So I have a momentary load on this battery. We're going to pause that. And we're going to see what happens. So let's zoom in just on voltage. So now my voltage at its peak is 12.15 volts
and my voltage on the low side we're dropping down all the way to 9 volts whenever we're loaded. So again, we're going to recap. We can't go below a certain voltage threshold whenever we're programming a car. Most manufacturers don't want us to go below 12.5 volts, and they want us to be around 13. So we have officially went down to 9 volts. And whenever you get into that voltage range, now is where you start bricking computers. Let's back out of that and let's look at our AC ripple at that same time. Look at that ripple going up and down. Let's zoom in a little bit more. Amazing how much ripple we have coming out of that battery charger. So this battery maintainer will definitely not work for programming a car. So we know step 1, battery maintainer, not going to work. Let's take that off the table and let's move on to a battery charger and see what that looks like. Now I have switched over to this Schumacher. They call this one a speed charger. This one can be 2 amp, alternating between 10 and 20 amp depending on the battery, and an 80 amp start. So 80 amp start means that it can do 80 amps very momentarily. So let's get this one plugged in and see what it looks like on the scope. I'm going to change the battery setting to standard voltage, and we're going to do a medium to large battery. As soon as the battery charger kicks on, bam, there it is. Off the scale. Okay, so that is our amperage. We're going to auto scale that one and see if we can get our amperage to come back into range. Okay, there we go. So I rescaled our amp clamp to measure up to 65 amps because that's all the farther my amp clamp can go. So you can see that we are getting bubbles of amperage that are getting pushed into this battery. So let's zoom in. Let's stop this. Let's zoom in. Let's go back a little bit. We're going to zoom into this bubble. You can see that the amperage goes from 3 amps and ramps up to, let's see, let's find out. Ramps up to 41 amps and then goes back down to about 3 amps. So we're getting this bubble ramp of amperage that comes through, so amperage is surging into that car. So let's see what happens at the voltage range. Let's zoom in on this little piece here. So let's look at this voltage. So if we look at voltage and we bring that down, that is giving us 13.68 volts right here, 13.68 volts. And let's drag that down to the bottom side, down to 12.87 volts. Sure, that's a little bit of an anomaly. So let's look in a little bit focused more. So that is bringing us to 13.27 volts to 13.18 volts. So we're in the voltage range with this battery charger, but our amperage is all over the place. We are way out of bounds when our amperage starts going up and down like that. So let's go back and look at our AC ripple. So let's go down into here for channel B and look at our AC ripple. So we still have quite a bit of AC ripple coming through, and it's all over the place as far as the ripple goes. So we are able to produce the voltage we're looking for out of this machine, but we're not able to produce the amperage we need, and we're not able to produce the consistent no ripple that we need coming out of that machine. Now that we know the voltage is good, but the amperage is kind of all over the place, let's see what happens when we actually load this battery down. Let's say that we're starting that programming process and we start to load that battery down. Let's see what happens to our voltage. Let's stop it right there. Now, with a load on it, let's zoom in even under that amp curve and see where our voltage is at. So here's our voltage. Let's drop that down. We drop down to 11.21 volts. And on the low side, we drop down to 11.8 volts. Again, manufacturers require that we have at least 13 volts, 12.5 at the minimum, to be able to program a car. So we are way underneath that. So we know that a battery charger not going to work. So let's take it to the next step, and that is a stable power supply, and we'll see the difference in those. Now we move on to the Schumacher stable power supply. This is a model INC 700A. This can produce a consistent 70 amps of power at whatever voltage you set. Right now you can see that I'm set at 12.4 volts, which is actually reading the battery voltage. This has the ability to maintain a stable power supply up to that 70 amps. So the voltage will stay consistent and the amps will do whatever it takes to maintain that voltage. Also, you're not going to get any ripple effect out of this. So it's a very clean and stable voltage. So this is the choice you want to go to whenever you go to program a vehicle with your J-Box. So let's get this hooked up and show you what it looks like. One thing before I do, my low amps probe is not big enough to fit around the heavy gauge wires that are on this stable battery supply. So I won't be able to give you amperage on this, but we'll still be able to look at voltage even when it's loaded. I'm going to turn channel D off because we can't look at the amperage anymore because of how beefy those cables are that are going on to that battery. So currently you can see that my battery voltage is right at 12 volts, 12.4. No problem there. So we're going to go over to the Schumacher stable battery supply. We're going to take it down to mode, and we're going to go to flash programming. We're going to take that voltage, look at that, 14.2 volts. As soon as I say go, we can see the voltage instantly change on our scope. So now we're at 14.2 volts on our power supply, and let's go ahead and zoom in here and see what our voltage is. We'll stop that, and we have a main voltage of 13.89 with peaks going to 14.1. We have a very small window of voltage from 14.17 to 13.46. So we have a delta of less than 3/4 of a volt. So very clean power coming out of that machine. So let's go down. We're going to back out of that zoom. Let's go down to our ripple. Let's look at where our ripple is. Look at how minimal that ripple looks. So let's take that off. You can see how minimal that ripple is. So very, very little ripple coming out of that machine, which is absolutely phenomenal. So let's go back. We're going to zoom out. We're going to turn it back on to live. So there's your live feed, and we're going to load this down. So let's see, we'll go ahead and switch over the display to amps so you can see the amperage being pulled on the display. So currently what you're looking at is the amps being pulled to maintain that voltage that we put in. And the voltage is 14.2 volts. So currently it's taking 6 amps pushed into that battery to maintain that 14.2 volts. So we're going to go ahead and load this battery down. We're pulling 67 amps to maintain our voltage. That noise you hear is the internal fan kicking on to make sure that the stable battery supply stays in good working order to cool down all the electronics inside there. I'm going to zoom in on the voltage so we can see that when I load this battery down, how much amperage is going to be maintained by the battery supply. So in this scenario, I cannot control how much amperage I'm putting on this load. So right now, my battery loader goes to 135 amps instantly. But what I want to show you is this. Look at the voltage that was maintained by this supply. We maintained 12.61 volts. So we're still over that 12.5 volt minimum, with 135 amps of load on it. But also, let's back out of here and let's take a look at that ripple again. Remember that ripple? It is so minimal. Look at how minimal that ripple is.
So with all that being said, here's the moral of the story. A battery maintainer will not work as a sufficient power supply to program a vehicle with your J2534 box. A battery charger will not work as a suitable power supply to maintain the voltage and amperage required to program with your J2534 device. You need to have some sort of stable power supply to be able to use your J-Box. Now, this particular unit is 70 amps. If you're running a BMW or a Volkswagen programming, you're going to need 100 amps. So make sure that you know what vehicles you're going to program so you can get an adequate power supply. I'm Chad from Flash Performance. Thanks for joining me. I hope you found this educational. If you have any questions, put them in the comments below. I'll do my very best to help you out. Make sure you give me a thumbs up, like, and subscribe to the channel. We'll see you next time.